Okay, welcome everybody. This is Electronics Club's first COVID presentation. We'll see how it goes. We handed out kits for the intent of using all of these. If you have a kit, that's great. If you don't, these are very simple concepts that are taught in this lecture today. So you could probably just follow along without an Arduino, or we'll have a solution for you to do everything online later. So first off, announcements. Basically, we have a whole bunch of open positions in the club: social media, workshop developer, webmaster, funding outreach coordinator, e-console representative. And then also we have office hours, currently by appointment only for obvious reasons. Yeah, you can just email electronicsclubosu@gmail.com. Is that our email, Edward?
I'll only put the link in the chat. Here's all our info stuff for the Slack, our Discord site, and email.
There you go. So you can use that to schedule an appointment if you want. If you have any questions, you can either just say, you can raise your hand. I'm watching all the people on the right here. And then, or you can just unmute yourself and ask the question. I don't really care if I get interrupted. There's only 9 of us here. Not like a huge 50-person lecture or anything. First, if you'd like to keep up with the slides, you can go to electronicsclub.osu.edu, click on meeting slides at the very top right, and you can hopefully find this presentation if we have it all updated. Next, so if you have a kit, actually, does anybody here have a kit? Might as well start with that. If you do, type yes, or hit yes on the thing. I'm talking specifically about the kit, not about just an Arduino. Actually, specifically the kit that we handed out. Okay, so there's a few of you. So, if you do have your kit, just kind of spread it out on your table and make sure you have everything that's on the screen. You can see what's used today and what we're going to use later. Maybe you can try to figure out exactly what we're going to do later on. But I guess we'll sit here for a second just to make sure.
Yeah, so one thing that if you don't have a kit or Arduino at all, you can go to Tinkercad.
I'm doing that later.
Okay.
I have that later in the presentation. And then if you have everything, great. If you don't, I guess just email or in our Discord. You can. I see a few people joined, but yeah, just contact us and we can get you the part. Obviously not for today, but okay. Moving on. What if I don't have a kit? You can actually follow the link and do everything completely online. Let's see what this does. So basically what you can go on here, you can do, let's see here. I think I can just do it with my email. Perfect. Okay. So you can go on Tinkercad and you can go circuits, try the circuits tutorial, try circuits. Yep, tinkercad.com. And hopefully, there you go. So you can do some basic components here, but specifically, you can just straight up plop an Arduino in here. There you go. So if you don't have an Arduino, you can literally just do it right on here. And I'm pretty sure there's a way to even, yeah, there you go. You can even get the code right there, and you can do it as text. There you go. There's your Arduino code right there. Oh, and your kit's missing about half of what's on the screen. That's awesome. Edward, you can sort that out. Okay. So, what we will learn. Basically, we're going to do, this is Arduino 1101. So it's very, very simple. What's an Arduino, how it works, structure of code, serial monitor plotter, inputs, outputs, and if we have time, you can ask questions about some more advanced programming. First off, what is an Arduino? Open source electronics program based on easy to use hardware and software. So basically, Arduino themselves put together these boards here. They are the Leonardo 101, Micro, Nano. And of course, the Arduino, the Uno itself. They do some of that hardware stuff. So they basically take a kind of complicated Atmel processor, puts all the different parts that support the processor on a board, and then they wrote some software, aka the Arduino IDE, and some lower level stuff inside the processor himself to make it so that you can code it easily. Normally you'd be doing like assembly stuff, and obviously we don't want to do that. So they made it very easy for people to be able to work with it. This is what the Arduino Uno, which is specifically what we are going to use. This is all the pinouts. If you want, you can just take a picture of this, or you can just Google it. You can see at the bottom right. That's where I got it from. But generally, left side is analog inputs and some reference voltages. Right side is digital outputs and some data communications. So serial, I2C, SPI, and then some PWM ports. That can be used for communication as well. And at the very bottom, you have some more debugging stuff that generally people don't use. So this is so just to go a little bit more lower level. This is more electronic. This is electronics clubs, right? We want to know exactly how an Arduino works under the hood. We're not going to go super in depth, but we have the power regulation circuitry over here. You can see there's a few capacitors and some voltage regulators. Also the power jack. We have the actual Atmel processor here. This is the one that does all the heavy lifting. That's where your code actually goes on, is that little black box. And we have the crystal oscillator, which runs both, or actually the crystal oscillator runs the Atmel chip, and then this actually little tiny Atmel chip, the 808U2, that actually is a second processor. So technically this thing has two processors on it. One's just a lot slower than the other. And this one does just USB communications. It doesn't really do any special, your code doesn't run on it. And your code shouldn't run on it, because if you were able to upload code to it, you could very likely break your system. So basically having this Arduino or this Atmel chip here makes it harder to break your system intentionally or not intentionally. And obviously USB port, it's not labeled here, but this is your reset button. This just sends a reset signal into the Atmel, so it allows it to hardware reset in case your code crashes or freezes. And lastly, we got the pretty LEDs. I love LEDs. All my friends know that. So you have L, which is an LED connected to pin number 13. TX and RX, which are connected to the serial lines, so you can see serial data going in and out, and the power LED, which, would you guess, indicates power. Wow. Just before we go on, is there any questions you guys have about how an Arduino works? I'll try my best to explain it if you do.
I had a quick question, actually.
Yeah.
Can you explain a little more what the oscillator does?
Yeah, so the crystal oscillator, it provides basically a square wave onto a line that the Atmel needs. So that actually determines the speed of the processor. But basically how processors work is they need to have a clock signal in order to run, like, at all. And so basically, like, it's getting a little more in depth than I can remember off the top of my head. But you can, every clock cycle is when an instruction is executed. So like if you have, compare this variable to this variable, depending, that sometimes it takes multiple clock cycles even. And by clock cycle, I mean a high and a low that's generated by the crystal oscillator. But like, comparing two things, that would be done on a clock cycle. And so the faster your clock cycles, the faster the processor goes. Did that kind of answer your question?
Yeah, no, that was great. Thanks.
Okay, perfect. I'm glad it did. If you want, if you're actually more curious about information like that, you can look up Ben Eater, that's his name, on YouTube, and he actually shows you how to make a computer on a breadboard. Actually, many breadboards. It's not very hard to fit it on one. So if you're very interested in how actually processors work under the hood, you can go look up that guy. Moving on. So first off, we're going to get the software. Most of you probably already have it if you already have an Arduino. But if you don't, go online, there's the link, and hit the Windows installer. Don't get the Windows app. I remember when it first came out, it was very buggy and very hard to connect to because it was an integrated app, and just those, like, the Metro apps are kind of weird. So just definitely do the Windows installer, or you can do the zip file if you want to have a portable copy. If any of you don't have the software / need to install it, you should hit no so I know to wait. Or hit yes if you already have it. Yeah, I can do that for you. There you go. Perfect. I don't know if you can hear my Discord, but I turned it off. Sorry if that was bugging anybody. Okay, once you get the software installed, you should change your no answer to yes. I'll probably move on once we have around 70 to 80% as yeses, just so we can continue with the lecture. So even if you do have it, make sure you say yes. I think we're actually up to around 60% of you. Actually, maybe even more. Let's see, we have, what, 5 out of, no, we have, we have 8 out of 11 right now. 9 out of 11. I can count. Okay, that's enough for me. If you really have problems, you can ask me to stop or slow down. So, when you get it, so anybody who does has it, you should open it up. And first thing you should see is a default sketch, completely blank. Basically, when the processor wakes up, it'll do a few memory management things, kind of set all the registers to 0, set all of its memory equal to 0, and then it'll jump to your code. Your code would be in this line setup. You put your setup code here. So for instance, you're going to change, we're going to go over it a little bit later, but you're going to do like your pin modes, maybe initialize some variables equal to a special number, or maybe connect to your serial, like start the serial. And then line 6, 7, 8, 9, that's your loop. So basically, once the processor's done with setup, it'll do a few more little things under the hood that we don't have to worry about. That's the code. That's the special code that I'm talking about Arduino wrote. But again, don't worry about it. And then it goes into loop. Loop basically just runs continuously. You can have, some serial print lines, which we're going to do later. Read some values, put them out into the serial. Going to do later. Read some stuff. Copy it onto the digital outputs. That kind of stuff like that. You can even do a little bit more complicated stuff, like this. This is one of my Arduino projects. So you can see, for instance, in my setup, I have the serial, just like I was talking about. Set up some NeoPixels. That's a future thing we're going to do, actually, a workshop later. You people in the kit, hopefully you have some NeoPixels. We did include them. Set up a pin mode and then digital write that to false. For instance, that's what some of my setup code does. And then we have a whole bunch of variables and a whole bunch of tabs. But that's an example of some code. So let's get started actually coding some stuff. Actually, JK, we're not going to code anything yet. Let's get started with the serial monitor and plotter. So, how about everybody, I guess, connect your Arduino. So go to, connect it up and then go to Tools, Board, and then don't hit the Nano, hit the Uno, which is that one right there, because that's what all you guys should have. And then once you're done with that, also, again, if you want me to slow down and repeat anything, just say so. I'm watching chat, hopefully. Then hit Tools and then Port, and this COM port will be different for everybody. So just click, hopefully there's only one or two. If you do see COM1, that's probably not what you want. So you're gonna hit the other one. And then tools, and then you click serial monitor. Now, this is what it should look like. Basically, you have your COM port up here. You can type something to send to the Arduino right here. And then your Arduino's output is right here. You can have auto scroll or show timestamp. Basically, that's just exactly what it sounds like. If you auto scroll or you see the timestamp, like when the message was sent. Down at the bottom right, you can change what gets sent at the end of your message. So that could be a new line, carriage return, or a new line, carriage return, or nothing. So that's useful for, it's put at the end so that if you have some code, yeah, you won't see any ports available if you don't have an Arduino installed, or not installed, if you don't have an Arduino plugged in. So just kind of follow along. You can go onto the Tinkercad once we get later in the lecture, like we were talking about earlier. They might have the serial monitor, but I'm not sure.
They do.
They do. Look at that. So you won't have to worry about this. You'll just basically follow along for whenever you do get an Arduino. So that's what I'm talking about with new line. It basically tells, you can use new lines to tell when the end of the string is, so that if you're trying to parse data, that's basically what people use it for. And then you got clear output, exactly what it sounds like. It just clears this box right here. And lastly, you got the baud rate, which is the speed at which the serial port is running at. Faster the speed, obviously, it takes more processing power on the computer side to process the data as quickly as the Arduino can send it. And obviously, it's going to take more processing power on the Arduino side, but it allows it to operate faster. So this is an example of what it would look like. You can see it connected up, and then now it's getting sample data. Does anybody know how, well, does anybody that has used an Arduino previously would know how to write this function or make the Arduino do this? Maybe just like quickly type it in chat or something. If not, that's fine. I actually show you the code for it exactly in a moment. Yes, serial.out.print. Actually, that's Java. You're very close. It would be,
Ah, damn it. I've been doing Java for too long.
it would just be serial.print. So this is the exact code that you just saw running. Basically, you do the serial begin 9,600. Again, that's the speed at the serial port. 9,600 is pretty standard, but it's pretty slow. Let me just go a quick Google search. I believe, yes, it's in bits per second. So 9,600 bits per second is what that means. And then it prints sample data, misspelled, of course, and then prints the milliseconds of Arduino. That's an internal counter since the Arduino turned on, and then delay 1 second or 1,000 milliseconds. So you can see it started at 0 and then waited around 1,000. It's not perfect because of other stuff the Arduino is doing. Also because the crystal resonator is not exactly at, it kind of drifts a little bit based on temperature actually. And then obviously, so it puts out 1,000, 2,000, 3,000, 4,000-ish. That's because it would count up 1,000 times, and then we would actually wait 1,000 at the same time. So that's why it's almost the same, but not exactly. Any questions on that before we move on? Okay, I'll take that as a no. Moving on. Next, we're going to mess around with the serial plotter. You can see it's right below the monitor. This is what it will look like when you first turn it on. You can't send anything with it, but you can receive stuff. It's pretty cool. Basically, all you get is you can change the speed. Also, these need to match within your code and within this, or else they're trying to communicate at different speeds and it just doesn't work. This is what it'll look like. You see it's deactivated. I plug in the board. Board boots up. Oh, would you look at that? Nice, beautiful sine wave. Now, this is actually being generated by the code of the Arduino, and it's not actually measuring anything. I'm not going to bother asking about how we actually generate it. I'm just going to show you. So, not that hard. Basically, we're going to do begin it again, and then print line. Print line adds that new line at the end to determine when it's the end of the message. That's useful for the serial plotter to know when you're done transmitting your message. Then we're going to do sine. Remember, millis I explained just a second ago. It's the amount of milliseconds since the board turned on. And then do a little bit of math on that to scale it to the right length to make it look nice and smooth. And then if we need to, in order not to overwhelm the serial port, you got to delay. Now, if you don't delay, like I said, you're going to overwhelm the serial port and you'll lose data. Any questions on that? Okay, perfect. Next, we're going to mess around with inputs. This is actually, we actually finally get to use some hardware, right? So, if you guys could make this circuit with your Arduino, a button, a breadboard, and 2 wires, and then copy down the code. And like I said, raise your hand if you're having problems. You can do that in Zoom actually, with doing a reaction. Oh, JK, no, you can't. It's clap. I thought that was raising hand. Okay. How about this? Hit no, or type no if you have a problem. Well, I guess if you have a problem, you just type it and type the problem directly. But you know what I mean. You have a kit? Are you sure you don't have a button? It looks, let's see here. Trying to find a picture of a good one. Yeah, this is it. That is what the button will look like in the kit. When I made the kits, I'm pretty sure I put buttons in there. You're 100% sure you don't got the button. Okay. I wonder if somebody made a few more then and didn't put the button in. Well, you can, if you want. That kind of sucks. You can just touch the wires together, I guess, to get the same effect as pushing the button. Sorry about that, though. But again, that's what the button looks like. And you can, the placement of it vertically doesn't matter as long as you place it like this.
Oh, I have a question.
Yeah.
I was wondering if you could give a quick explanation of the wiring of a breadboard, because I can never remember it.
Oh, yeah, it's not too bad, but of course. So these rails on the right and left, you can see there's basically 3 sections, right? There's a section here. I don't know if I hope you can see my mouse, right? I want to make sure about that.
Yeah, I can.
Okay, good. So there's a section here, and then there's the middle section, and there's a section on the right. The left and the right sections, they're all connected vertically. So all of these are connected, and then all of these are connected, but they're not connected together. And on the right side, all of these are connected, and all of these are connected, but they're not connected together, like next to each other. And then these labeled A, B, C, D, E, F, J, I, F, G, H, I know the alphabet, I swear. These are all connected left to right in this picture. So you can actually see these dots right here represent a connection. So you can see there's a connection here onward, but nothing else is connected to it. Here onward, and then the left side here to here, and you can see a wire is connected there. So that's going to be connected to the button, and then same thing from here to here, and then connected to the wire. Does that make sense?
Yeah, thank you.
Perfect. When you have your circuit made, why don't you say yes in the chat or hit yes in the reactions? Okay, seems like everybody's doing pretty good on that. Perfect. So, does that, okay, now say, never mind, don't say yes again. Does everybody, how about this? Does everybody have the code typed in? Say no if, how about this? Say no if you don't have the code typed in. There we go. Almost, good. Okay, perfect. We're waiting on Connor so far. Oh, there's two Connors. Other Connor also. There we go. Okay, so as far as I can tell, most people have it typed. So what you're gonna do is hit this button right here, the one with the arrow. Once you make sure that you have, let's go back quickly. Make sure that you have your board set to Uno, not Nano. That's wrong in the presentation. Your COM port set up, and click on serial monitor. Then hit the upload button. And hopefully you'll see a whole bunch of ones. And then when you press the button, you should see zeros. If you don't, ask me. And I can try to figure out what's wrong.
I get an error that said button pin was not declared in the scope.
You're missing line 1 then. It should be above the setup. Or you mistyped button pin.
Ah, yeah, I see that. Yep. Thank you.
Connor, how do you say your last name, Connor B?
B height.
Connor B height says there's a serial monitor in Tinkercad. It's on the lower right if you are working in Tinkercad.
I did have a question.
Yeah, what is it?
You have pin mode, button pin, and then you do input pull up. I have previously seen either input or output, but neither input pull up. What does that mean?
So, the way that the processor looks for, basically when you do a digital read, the processor will look at a pin and compare it to around a middle voltage. So basically, if it's greater than 3.5-ish, or if it's less than 3. Actually, I lied. I think it's around 1 volt. We can look up that later. But it compares it to a voltage. How about that? I'll just leave it at that. The exact voltage, I don't know. But if you have, so basically, if you just do input, it does not, it basically just, this is hard to explain actually. If you just have input and then you do a digital read on a floating pin, and a floating pin is defined as just a wire that's disconnected, right? So it's kind of just like floating in the air, for instance. It can actually sway above or below this reference voltage that I'm talking about that I don't know the exact voltage of. So you can sometimes get, even if the button is disconnected, or the button is, the button is up, not pressed, if that just leaves the wires disconnected, that can actually cause the pin to be floating, is what we call it. And then you can actually have, based on RF interference, like from your mains voltage in your walls could even, or like radio signals in the air, that can actually, the pin or the wire can act as a antenna and it can actually give false positives because the voltage is just disconnected. All of that is to say, input pull-up, the processor within the silicon actually has a resistor through a transistor to 5 volts. And you can enable or disable this resistor by changing it to input pull-up or just input. Input pull-up enables that pull-up resistor, is what they call it, and it, like it implies, it pulls it when the wire is disconnected. It pulls it up to 5 volts. Okay, so that makes it so it's not floating anymore. It now makes it so through a resistor, it's getting a high voltage, and that's why when you digital read, when the button is up, when the button is not pressed, it reads as a 1 because it's the input pull-up is pulling it up to high voltage. And then when you press the button, it bypasses the resistor to ground. So now this 5 volts is going, let's say we're looking at the Atmel the processor side of that little circuit that I just described. The processor pin is connected directly to ground through the button. And then you needed a resistor there instead of just connecting the processor to 5 volts. You need the resistor there. So now that resistor is going from 5 volts through the resistor through the button to ground. So if you didn't have the resistor, it would actually blow up that trace within the processor. Did that answer your question?
Yeah, awesome. Thank you.
I'm very good at over-explaining things, if you wouldn't have guessed.
Huh.
There was a question, is there ever a pull-down resistor? Some processors do have pull-down resistors. The Atmel that's using the Arduino does not. I have seen, however, I don't know if you've heard of Teensies. Some Teensies do have, Teensy is another type of microcontroller. Those do have pull-down resistors. And so basically you'd change the circuit to be, instead of to ground, you'd actually put it to 5 volts over here. And so it'd be default down to 0. And then when you press the button, it sends 5 volts through the circuit. You can also make your own pull-down resistors. If you just put a resistor into the circuit, you can change this wire. Let's see. Yeah, so you can put this wire on 5 volts, and then you can have a resistor. It's hard for me to come up with it on the spot, but you can add a resistor to the circuit, and you can make it so a pull-down resistor. Any other questions? And or is it not working for anybody? Okay, so we're gonna move on. Sorry about that. So we're gonna go into outputs. So basically what we're gonna do, you're gonna still have your button, but this time it's wired very similarly, except you're going to, is it the same output? Yeah, it's this, oh, okay, so your button's the same, but now we're adding a resistor and to pin 13. And then copy down this code. If you have any questions, ask Edward or Connor. I'm gonna be right back. Okay, I am back. Sorry for the interruption. Is anybody having troubles?
Is there any reason that we switched which ground pin we're putting it in? They should all be the same, right?
You're correct. They are all the same.
Okay.
It's just to make the picture a little bit more clear, so we routed it around the bottom, or to not have wires crossing.
Okay.
Has anybody gotten this code to work? And can you say what we did? Take that as a no. Has anybody actually finished writing the code and doing the circuit, is what I asked. Perfect. Connor, you are correct. We basically just created a very complicated NOT gate. That is very true. I definitely should have mentioned that. If your LED isn't if the circuit isn't working, try switching your LED, like just flipping the legs of it. There is an example of what how you should do your LED. The negative should be on the resistor side because that's going to ground. We're going to try to keep this presentation at an hour 15, maybe an hour and a half in total. We'll see. I believe that's all we'll have. That's all we'll need. If you guys have to leave sooner, though, I could speed through the last slides. Oh yeah, that was definitely a good idea, Gary. We could probably publish this code. That'll be a next year thing for sure, though. Oh yeah.
We do have a GitHub organization. It's not quite set up yet, but it's in the works right now. Yep. Thank you for coming, Connor.
He left.
F in the chat.
Yeah. Oh well. Okay, we're gonna move on. Does anybody is there any reason we shouldn't move on? Does anybody have any questions? Is it not working? Because if not, we're gonna go. Okay, we're gonna continue. Oh, of course an LED is broken. Sorry about that. If there wasn't a way to really test them. Well, I guess we probably could have tested them, but we were making the kits so quickly, we weren't able to. Okay. So we're gonna do analog inputs. Basically, tear down what circuit you had, and then we're gonna use the analog 0 with the photoresistor. It looks a little bit like that. Let me pull up a proper picture. That's a picture of your photoresistor. Yep, goodbye.
Just wondering.
Yeah.
What does a photoresistor do?
Basically, it's exactly what it sounds like. It's a resistor that changes to photons.
Okay.
Yeah, so what you're gonna do I don't know if you have the circuit or not, but when you use the circuit, you're gonna be able to, the circuit will print out the value of light that's coming into the photoresistor. So if you put your hand over it to get it dark, it'll change one way, or if you shine a really bright flashlight, it'll change the other way.
Okay. Thanks.
Yep. Anybody have anything else? Any other questions?
Quick question.
Yep.
With stuff like photo pin and the button and stuff like that, I'm guessing those are like pre-written names for both of those components that just Arduino just made it so board understand, like, because obviously photo pin is just a name, but I'm guessing I don't know how to word it, like we write photo pin and then the board understands what we're referring to, just because photo pin's like a pre-made name for the sensor.
You're very close. So photo pin we actually define on line 1. So photo pin is something we actually wrote. However, there is something very similar to that, which is A0. That is a special phrase that Arduino recognizes.
Right, that's the analog input, right?
Yeah, that's A0 analog input 0.
Okay. I gotcha. So we're just assigning the photo pin to an analog input of a specific location, and that's
Yeah.
how it knows what to get data,
Yep.
I guess, from, right?
And the reason that we would, you might ask, why wouldn't we just put A0 in here in replace of photo pin, and here in place of photo pin? And you know what? You could do that. And if you have the Tinkercad in front of you, you could do that, and it'll work the same. However, now let's say you want to change it to analog 1 for some reason, or you want to add another one, and you have to change it to you have to change it to analog 1, for instance. If you had 2 of them separately, you'd have to change them twice, right? But with this system, you only have to change it once, and it changes both of them at the same time.
Yep, makes sense.
Has anybody gotten this code to work yet?
I have gotten my Tinkercad to work.
Awesome.
So what is this supposed to do exactly?
So basically what it does is it allows you to read, oh yeah, use the plotter. The plotter is pretty cool. It allows you to read the amount of light coming into the sensor, and it's printing it out to the screen. So if you take like a flashlight from your phone and put it right on the sensor, it should go very far one way. I don't know the actual values. And if you put your hand over it and make it completely dark, the photoresistor is what I'm talking about, by the way, it'll go the opposite way.
If you are on Tinkercad, you can click on the photo resistor, and then it has a little slidey scale to go from dark to light.
Yes.
Definitely much more fun in real life, but Tinkercad is real cool to play with as well.
Yeah. Definitely more fun in real life for sure.
This is the first time I've ever seen this existing before, which will
Tinkercad?
be, yeah.
Yeah, it's pretty cool. I've never used it myself. I've always done like real life, hardware things. I've always had the hardware sitting in front of me. But Edward
It
showed it to me. It was really
would
cool.
be really great just in case you don't have the components in front of you, if you need to like test out what certain things do before you order them online.
Oh yeah, I'm sure.
Oh yeah.
Your value does not change. Let's see. I would double check your wiring and make sure you have it to analyze, that middle part in between the resistor and the photoresistor. Make sure that goes to ground. Or make sure that goes to analog 0. Make sure the other side of the resistor goes to ground, and then the other side of the photoresistor goes to 5 volts.
They have a whole lot of components as well. They have like op amps,
Bye, Nick.
timers.
Thank you for coming.
Oh, goodbye.
Yeah, they do have a lot of cool stuff.
AT Tiny. Yeah.
Maybe I should mess around with it myself more.
No, yeah. It looks like they have inductors and capacitors, so you can test out different RLC circuits and whatnot.
Oh yeah, very useful for 2020 and physics 1251.
Yeah.
What did you say was supposed to happen once you ran the code?
You need to have the serial monitor open or the serial plotter,
Okay.
and then it should be printing out a whole bunch of numbers.
The same numbers or different numbers?
It should be different.
Okay. Yeah, I think I'm getting the same number. So.
Okay. Do you want to try and figure out what it is?
Oh no, I'm sure I can figure it out. I just gotta wire it probably.
Okay.
Thank you though.
Yeah. Make
when
sure also. Sorry, what were you gonna say?
when it is working, if you shine a light on it, the number should change.
Yeah. Make
Okay,
sure
great,
that.
thanks.
Yeah. Make sure that you have. Remember when I said the board go, or make sure you don't have them all in the wrong lines. So remember those lines that I talked about on the breadboard? Make sure that this is one line, this is a different line, and this is a different line. Make sure you don't have them rotated wrong.
Yeah, I just covered it with my hand and the numbers are changing, so I think it works.
Ah, perfect.
Thank you.
Yeah, Declan, I would love to help you. If you have a camera, you can try pointing at the circuit and I can try looking at it. Or if you want, you can try to share your screen. I can look at your code. That's basically the best I can do. If I was in real life, I could just walk on over and try to help you. Would you want to do any of those things or you want to just kind of move on? Ah, perfect.
All right. There you go. Okay.
Let's see.
It's really hard to see, I know. Okay, hold on a second. So this wire is 5 volts.
Is
I
your
don't know.
5-volt connected to your photoresistor correctly?
Yeah, it's right here. I can tell it's really hard to see. Sorry about that.
You're fine, you're fine.
Okay. So the purple is the 5 volts, and that's on the same node as the photoresistor. And then the photoresistor goes to the same node as the orange wire. And the orange wire is on A0.
0.
And then the resistor is here bringing the ground over from the Arduino just directly.
Okay. And then what is your serial plotter or serial monitor saying?
Serial monitor.
Yeah. Like what are the, because that honestly looks right.
Give me a second.
Oh, here, I probably have to stop sharing my screen so you can.
Serial monitor. Where is it? Okay.
You're just getting ones.
Uh-huh.
Can I see your code?
Uh-huh. Wait, how do I just like share the entire screen? Is there a way to just like share the whole screen? Oh, here it
I'm
is.
not sure.
Okay.
There we go. Let's see.
So what did you want to see? The
Yeah, this is what I wanted to see.
okay.
Dang, that looks right. Defined as an input, analog read, serial print line. How about this? Open up your serial monitor again, and then yeah. Now move the wire from the analog. Move the analog wire onto the 5 volts.
All right. I did that.
Okay. Try moving it to ground.
I've done it.
Okay.
Um,
How about this?
Wait, which side of the wire did you mean exactly?
Move. So if we have connect A0 to 5 volts, and then
Oh,
try
okay, I see what you
0
mean.
to ground. I want to see if that's going to change your numbers.
Okay, A0 is directly on 5 volts now.
Okay.
And now it's on ground.
Okay. Let's change your code to do A1
Okay.
instead of
Do you think
A0.
you think the A0 is broken on mine?
Yeah, A0 might be broken.
Okay, I don't know why I closed the monitor.
That's okay. You have to upload the code.
Oh, well. Maybe that was the problem before.
Oh, yeah, maybe. Okay, now hook up A1 to 5 volts.
Mm-hmm.
There you go. Okay, now you can Oh, here, that's actually a perfect example of what I was talking about with floating voltage. If you just have it disconnected, how it's all those random numbers. Just by the way. Okay, so now try recreating your circuit with A1 instead.
Mm-hmm. Yeah.
And maybe that'll work better for you.
Okay, there we go. That looks like it's working now.
Perfect. Awesome.
Yeah.
Okay. I believe, yep, that's the entire presentation.